Algebra class, let's go ahead and knock out this next homework. I just got 9 problems for you today. This is really going to be a cakewalk. It says in exercise 1 and 2, use the line of fit and the residuals to interpret the strength and direction of the correlation. So the table shows the total cost, and they say the total cost is Y in dollars, to buy X. So that's going to be my X axis there, right? Which is 8 by 10 photos. The equation they're using is y equals 4x models this data. So remember, they're saying use the line of fit and the residuals to interpret, okay? So they're going with this equation, and they're going with these residuals. I see the residuals here are 1, 6, 10, 9, 3. These are positive residuals, right? And then the negative ones are -4. There's only one of those. Not crazy about this line of fit because we have a lot more above it than is below it. And we got some pretty big numbers here, 10 and 9. They're way far from what we're looking at here. So looking at this, I would say, well, we know as X increases, Y increases, right? For the most part anyways, the only difference I see there is where it went slightly down right over here. It says, so the direction of the correlation is definitely positive correlation. And I guess if I was going to draw this out, just leave myself some room here. If we had 0, then the cost would be 1, right? So we could say this is 1 over here. And then when it's 1, it's 10, right? There's the total cost. So 1, and well, if that's 1, then 10 is probably about, we'll say right here. And okay, so we know when this is 1, we got 1 about right here, right? And then, so I'll put a dash here so we don't confuse that for a dot. When we're at 2, we're at 18. So if this is 10, 18 is probably sitting about right here. So when this is 2, this is sitting about right there. And then get to 3, we're going to 21. So now at 3, now from 18 to 21, this is going to be a big jump. So maybe about right here. And then from 4 to 19. So at 4, we're only going 1 up from 18. So that's going to be about right here. And then 5, 16. So at 5, we're actually going lower than 18. We're sitting about right. I'm thinking about right here. And they're modeling that y equals 4x, okay? I'm using this equation, y equals 4x. So this would be a rise of 4 for every 1, right? So if I'm doing this at 1, I'm going to be at 4, and I guess 4 would be about right here for my first point. At 2, I'd be about at 8, right? And so that would put me about probably here. At 3, I'd be about 12. So I would put that about here. At 4, I'd be about at 16. I'd be about here. And at 5, I'd be, well, at 20. And that would put me about right here. So my line is actually going to be coming, let's see, well, from here. I guess I should put this one more like that. Sorry if it's not totally straight. Ooh, my mouse is all over the place. There we go. So that's our line of fit, okay? And as we've seen, just like we've seen over here in the data, there's only one of them that's going to be below it, right? Right over here at a -4. All the rest of them are going to be 1, 2, 3, 4, looks like 5 above it, right? So there's a wide range of residual here because these over here are not even close to this line over here, right? And the absolute value of some of them is very large, very large. 10 and 9 are definitely large numbers. So the correlation is weak, okay? The strength of this line for this is weak, all right? And it says you can conclude that there is a weak positive correlation. We know that it's going up from left to right, so it's positive. We know that the correlation is not really tightly around this, so it is weak. Okay, so we can conclude there's a weak positive correlation. The total cost tends to increase somewhat as the number of photos purchased increases. So the more that I purchase, right, the number of photos that I purchase increases, the price increases, right, somewhat. In this case, it kind of, when I got to this point, it started actually decreasing a little. All right, let's go ahead and go to number 2 now. Let's see. Number 2 is for you to do. I'll let you take a look at this for a second, work it. Now I'm going to do number 3. Number 3 and 4 says identify the number of positive and negative residuals. The residual with the greatest absolute value and the residual with the least absolute value is the model a good fit. Now they're saying the table shows the number Y of trees sold at a nursery from February to July. In this table, X equals 1, all right, represents February. The equation Y equals 60X plus 4 models the data, all right? Excuse me. So we're going to go ahead and pop these in there. Let's see. I'm going to try to make a little graph again. And we're going to go by 50s here. We're going to say this is 50. We'll put this at about 100. I'll make this about 150. And this would be about 200. We'll put this at 250. Actually, I didn't make this big enough, did I? Because they want me to go all the way to 370. So I'm actually going to take this, alter it just a little bit. I think what I'm going to actually do is go by hundreds instead. So that would put me at 100. Put this one at 200. Put this one at 300. And we'll throw this one at 400. That should be able to take care of all of our numbers there. Over here, we just got 1 through 6. I'm just going to put this as, well, 1. This would be 2. This would be 3, 4, 5, and 6. All right, so 1 is at 68. 68 is going to be sitting, well, just above half here. 2 is going to be at 135. So that's going to be slightly above 100, right? Probably sitting about here. It says 3 is 172. So 3 is going to be somewhere over here, not quite at 100, and not quite at 135. So probably about here. And 4 is going to be at 245. That's going to put me about right here. 5 is going to be at 300. 300 is about right here. And 6 would be at 670. 670 should be about right there. All right? These are our coordinates. It says here in the table, x equals 1. Okay, so these are 1, right? And then it says the equation is y equals 60x plus 40. So our line is going to be going up by 60, and it says plus 4. So we're starting at the number 4, right? Not quite at 0, right? Then we're going to go up 60. So the first one will be up 64, right? And that's going to be about right. Let's see. Well, 64 plus 4, 60 plus 4 would be 64. That's going to be just below 68 on our first one. Then, let's see. I wonder if I can get a different color here. Oh, yeah, that'd be great. Let's put this in blue. Okay. And then the second one's going to be at 2. The next one's going to be twice this, right? So it'd be 120 plus 4. That's 124. So this would be about 124 here. And we had 135 there. So this is just going to be below this one. Next would be 3 times 60, right? And all I'm doing is replacing, right? The first one I replaced x with 1, right? And I got 60 times 1, that's 60, plus 4 is 64, right? So according to this, 1 is going to be at 64, right? And we could say that 68 minus 64 is a residual of 4, right? This one was at, see, 135. I think I'll do a little different. Minus, we said if this was 2, this would be 124, right? So 124. That's going to put me at 19. Oh, no, 11 actually, right? So I'm going to put this at minus 64 over here. Just going to do it underneath them, make it a little easier on us. This is minus 4, of course, minus 11, because it's underneath that line. And actually, these points are above it, so I take that back. These would be plus, right? Because the points are actually above it. And then over here, we've got, if this was 3, this would be 180 plus 4, 184, right? So this time it's going to be different because I'm going to be taking 184 and minusing 172 because that's a bigger number, right? And that's going to give me 0. That's a difference of 10. This is going to be minus. So this 182 is going to be above our 172. And that's probably going to be about right here. And then if this was 4, let me erase it. If x was 4, this would be 60 times 4, that's 240. 240 plus 4 is 244, which is less than this by 1, right? So this would be a positive 1. So this would be just right underneath this one. If this was 5, it'd be 60 times 5, which is 300. 300 plus 4 would be 304. As we can see, that's a difference of 4, and it's going to be underneath it this time. So we're slightly above it at 304. And then 6 times 6, well, that's 360. That's 364, which gives us a difference of, looks like 6. Positive 6. So this is going to be slightly below it. So the line that they gave us is actually coming through here. I'm sorry, my graph is a little off, but I'm trying to show you that we're going through these dots here. And we have 1, 2, 3 that are above it, 1, 2 that are below it. Actually, 1, 2, 3, 1, 2, 3, 4 that's above it, 2 that's below it. But they're very close except for here and here. All right. So when they ask us what is the identify the number of positive and negative residuals, we've got, well, positive residuals are, where'd my dot go here? There we go. 1, 2, let's just circle all the positive ones. How's that? 1, 2, 3, 4. So there's 4 positive ones, and then 2 negative ones. The residuals with the greatest absolute value, well, that's going to be 11. And the residual with the least absolute value will be 1. All right? Is this model a good fit? Pretty good fit. I mean, there is a couple that are a little bit out there, but for the most part, it's pretty tight on there, I would say. Let's find out what the book says. The equation that models the data is y equals 60x plus 4. We see that we have 68. The y value is 64, just like I said. That's a difference of 4, right? Positive 4. Then we've got, if it was 2, they said 138 for theirs. Ours would be 124, just like I said here, which gives us 11. Over here, it looks like I made a little error. I put 10. And I'm sorry, this should have been 4, right? 184. So I did make a little mathematical error there. Erase this and correct it. Egg on my face here. This should have been 184, and this would have been negative 14. Oh, I'm sorry, negative 12. Wow, I'm really struggling here. Even when they wrote it in front of me, I didn't get it. All right. That makes sense there. Then I've got a difference of 1 over here, negative 4 over here, and 6 over here. So the rest of mine were correct. All right, now it says to find each residual, substitute each x value to the equation, and then substitute that value for y value given. That's exactly what we did over here, right? And so it says there are 4 positive residuals. That's what I said. 2 negative residuals. The residual negative 12 has the greatest absolute value. So that's absolutely right. That's bigger than 11 was. And the residual 1 has the least absolute value. The absolute values of the residuals are relatively small compared to the y values. And if graphed as a scatter plot, they will be more or less evenly dispersed about the horizontal axis. So the model is a good fit. All right, that's everything I said, minus my little mathematical error. Apologize for that. Let's go ahead and go to number 4 as I try to forget it. You have number 4 to do. Same thing that we did with number 3. I'm going to do number 5 now. Tell whether the correlation is likely in this situation. If so, tell whether there is a causal relationship. Explain your reasoning. The time spent talking on a cell phone and the remaining battery life. Well, I think that there's definitely a causal relationship here because the more time that goes by, right, the less battery life that I'm going to have, right? Because I'm going to be using power. So tell whether the correlation is likely situation. Yes, it is likely. And I think it's a causal relationship because you can pretty much say that as you talk on the phone, you're using a power. So there is a negative correlation and a causal relationship. I guess they were looking for a negative correlation instead of likely. Negative because, as we said, and I'm just going to put this in perspective over here, as my battery as time goes by, right, I might start here at 100%, and my battery life is just going to get shorter and shorter as time goes by, right? So that's a negative correlation, and it's casual because it definitely one depends on the other, right? Time is definitely going to affect the amount of power that I have there, right? The more time you spend talking on a cell phone, the more you would drain the remaining battery life. All right, number 6 is for you to do. Number 7 is mine. Tell whether a correlation is likely in the situation. If so, tell whether it's casual relationship. Okay. The number of hats you own and the size of your head. Wow. I don't think this is going to be a real big correlation here. Because I mean, unless you have like this humongous sized elephant head that no one makes a hat for, I don't think it matters what the size of your head is in reference to how many hats you might buy for it. Let's see. So tell whether there is casual relationship. I would not say this is going to be casual. There is no correlation between the number of hats that you own and the size of your head, because buying more hats will not change the size of your head. Okay, 8 is for you to do. So they hit a person's hair, color, and job. All right, I'm going to go to number 9 now. This looks like a doozy. The table shows the number Y, okay, in billions, okay, in billions of text messages sent each year from 2015 through 2019, okay, in the United States. So these are text messages, not the year. These are the years that go by, 5 years, okay, from here to here. In the table, X equals 1, okay, represents 2015, all right? So this is 2015, 16, 17, 18, and 19. The equation is Y equals 75X plus 1,602, which tells me at the beginning of 2015, there was already 1,602. Wait a minute, this equals 2015. So I guess it would be, we're starting at 0. That would be 2014, would have ended with this much. The residuals are shown in the table. Okay, they give us the residuals. Wow, there's some big residuals. Interpret the strength and direction of the correlation. Interpret the slope and y-intercept of the line of fit. Determine whether there is a causal relationship. So first, interpret the strength and direction of the correlation. As time increases, the number of text messages, let's see, in billions, right, is doing what? Well, first it went down, and then it started going up, right? The residuals here show that there were 1, 2, 3 positive residuals, right? And 1, 2 negative residuals. The fact that they're so far from each other kind of tells me there's probably going to be a weak correlation. If we make our, hold on a second. Sorry about that, had a sneeze. So let's look here. The last data value is greater than the first data value, right? Right here, it's bigger than this, right? And the residuals are relatively large. These are really large differences. So there's a weak positive correlation, right? As time went by, it is going up eventually, right? I mean, 2098 is bigger than 1,898 or 89. So it is going up, right? But it did kind of go down and then up, right? So the slope of 75, and that's what we have over here, 75, means that the number of sent text messages increases by about 75 billion each year. The y-intercept was 1,602, would correspond with the number of billions of text messages sent in 2014. That's what we discussed earlier, which is outside of the range of the model. So an increased availability of texting devices over time may result in more text messages sent. And that's what they're describing here. So the first one, interpret the strength and direction, right? The strength is the strength is very weak, right? And the direction is going to be, well, the last one is greater than the first. So the residual are relatively large, right? There's a weak positive correlation. The last was bigger than the first, so it is going up positive, and it's weak because of our residuals. B, interpret the slope and y-intercept of the line. The slope is 75, that's of the line, right? And it really doesn't fit it well because the y-intercept is 1602. It tells me that it's outside the range of the model, right? So it says interpret the slope and y-intercept. The y-intercept was 1602, right? So it's saying the y-intercept, the slope of 75 means the number of sent text messages increases by about 75 billion a year. The y-intercept 1,602 would correspond with the number of billions sent in 2014, which is outside of the range. And so the increased availability of the texting devices over time. They're saying determine whether there's a causal relationship. Well, they're saying here, increased availability of texting devices, so we got more texting devices, over time resulted in more text messages. But the passage of time does not cause more text to be sent. So there is not a causal relationship here, okay? I'm more inclined to believe that since there's more people on Earth, we're getting more people with phones, and that's causing it to happen. So that would be more of the relationship there. All right, that's all of them there, and we'll see you in class for grading. Have a great night. Sorry, I couldn't find any place to put this out of the way. See you in class for grading. See you later.